This week, learn how to make inset figures to zoom in on a region of a plot using Matplotlib with radar data as an example. Welcome to another MetPy Monday. Hello, I'm John Lehman, a software engineer for Unidata. This week, I want to talk about how to make an inset figure, or an inset axes rather, in Matplotlib, and how you can use that to zoom in on a region of a plot. This is really great for posters or presentations or even publications, as you can get a lot of mileage out of showing the overall scope of your data and then zooming in on one or two specific interesting features. This used to be a lot more difficult than it has become in recent versions of Matplotlib, and I want to make sure that you're aware of these. I'm going to be using some code from the MetPy examples to get some radar data to plot and play with here. So everything that I've already got typed on the screen here comes out of MetPy's examples almost exactly as it is shown. So if we look at the top, we've got our imports, Matplotlib, NumPy. We're using the getTestData function from MetPy's cbook module, the level 3 file to read in that radar data NIDS file, and then color tables from MetPy.plots. This will be for the radar reflectivity color table that we have with MetPy. If you want to know more about color tables, we have some past MetPy Monday videos on using MetPy color tables, as well as creating your own color table just last week. In the block of code that we've got from the example, we're using the getTestData function to retrieve the based reflectivity, the bottom tilt. And then we're doing just a little bit of math here, pulling that array apart and taking the azimuth and range values and converting them to XY values so we can plot them. Again, there's nothing too fancy going on here, and it's not the purpose of this video, so we're going to leave that code as it sits. But definitely go check out the example if there's something in there that you're not sure about. So let's get to making a plot. I'm going to create a figure and an axis at once using plot.subplots. I want one row and one column, and I'm going to specify a figure size of 8 by 8. Remember, this is whatever is set in your Matplotlib RC file. By default, that will be 8 by 8 inches. Next, we need to actually plot the data, but we need a color table to do that. So from the color tables module, I'm going to use the get with steps method. And if we look at documentation for get with steps, it takes the name of the color table, the starting value, and what increment we want to step in. This color table is NWS reflectivity. I want to start and step in increments of 16. Now we're ready to actually plot the data. I'm going to use pcolor mesh, which the differences between IMShow, pcolor, and pcolor mesh are a topic for a whole different video. We're going to use the X locations, the Y locations, and the data. And then we need to set a norm and a color map. So I'm going to say norm equals norm, CMAP equals CMAP. And those actually come from up here. If we look at the doc string, we see it returns a norm and a color map. So we're going to pull out those returns using the unpacking syntax. And if we run that, we get this plot. Not too bad. We see there are some interesting things going on in this radar image that we might want to zoom in on. One little tweak that I'm going to do is set the aspect ratio of the plot to be equal aspect so we don't distort, and to use the data limits to determine the plot bounds. So there's a very subtle difference there, but it's an important one to make so you don't accidentally skew that data. So now it's time to make our inset axis. I want to look right here in my plot. So first we need to create that inset axis. I'm going to call it axINS. And we create it off our main axis using the Inset Axes method. In here, we're going to pass a list in which we describe the lower left corner of that inset axis, its position in terms of axis relative coordinates, so 0 to 1 in x, 0 to 1 in y. Then we're also going to specify a width and a height in axis relative coordinates as well. So I'm going to put it in the center of the plot, the lower left corner in the center of the plot, and make it 0.47 or 47% of the axis width. So that creates the axis, but now we need to plot some data on it. So I'm going to use pcolor mesh, x locations, y locations, data, norm, and CMap just as above. We're going to set the aspect ratio the same as we did above as well. But that would plot everything. So we need to plot a smaller portion of the data. And looking at the plot here, I'm going to go from an x value of about -40 to 20 to capture this feature here, and from a y value of -30 to 30, so right there around the center of the plot in y. So we'll use the set xlim, -40 to 20, set ylim, -30 to 30. All right, so we have that inset axis. You see it is bottom left corner, right at the center of the plot, and it's almost that half width and half height of the plot. So not too bad, except I really don't like these numbers. Though right now they're the only way we have to know what region of this plot the blowup came from. So first let's remove those tick labels, and then we'll figure out a way to indicate where that came from. To remove the tick labels, we're going to use the set x tick labels and set it to empty string, and set y tick labels to an empty string as well. So now we have that plot with no labels. We're looking better. What I really want though is to put a box around where this zoom is from and some lines indicating that it's coming from there, because you could have multiple inset axes. Well, you used to have to do all of that manually, figure out where and what coordinate system you want to draw things and how to get the lines to go to the edge of the inset. You no longer have to do that now, because on the main axis object, we can call indicate inset zoom with the inset axis in that call. And now we get a little box and the lines. Notice that this returns several things to us. If we don't want to do anything with those and we don't want to see that output in the notebook, I can just assign that return to underscore. Underscore is sort of a throwaway variable name that we all agree means I'm not going to really use this. It's sort of like using temp, but it's an agreed upon convention. All right, so there we go. Now we've got a plot of radar data with an inset axis and some call out lines to indicate where it came from. I hope that you can use this in your next presentation, and I'll see you on next week's MetPy Monday.